Now I am going to start a very important topic which is called eigenvalues of matrix. How we calculate eigenvalues and corresponding eigenvector. This is very important topic. Then we go for in detail what are the properties of eigenvalues and eigenvectors. So it's very important. Please stay with me. So how we calculate eigenvalues, and I will explain. I will tell you about some tricks method also in this lecture. So it's very important. Please take care of this one. So what is eigenvalues? First, I will define the definition. Let A be a square matrix. A must be a square matrix, a scalar. A scalar lambda is called eigenvalues. Eigenvalue of the matrix A if there is a non-zero column vector. What is column vector? Which is having that matrix which having only one column, that is called column vector. X non-zero such that Ax is equal to lambda x. X is called eigenvector. So scalar lambda is called eigenvalues, eigenvalue of the matrix if there exists a non-zero column vector x such that Ax is equal to lambda x. X is called corresponding eigenvector and lambda is called eigenvalue. Now how we calculate? So first I will tell about some theory of that, how it came. So see, Ax is equal to lambda x, correct? Lambda is eigenvalue, x is eigenvector. How we calculate lambda and how we calculate x, I will tell you in theory. So we can write Ax minus lambda x is equal to 0. Here 0 is not a scalar 0, it's a matrix 0, whose all elements and these are 0. So this one we can write A minus lambda I of x is equal to 0 because x common, so lambda we multiply with identity matrix because this is matrix only. So because now take determinant both sides. So determinant of A dot B we know very well. Determinant of x, what is determinant of 0? 0 because it's not equal to 0. So what is 0? A minus lambda I is equal to 0. This is called characteristic equation. Determinant of A minus lambda I is equal to 0. It's very simple. So how we calculate eigenvalue? Using characteristic equation. So first of all we have to write characteristic equation. How we write characteristic equation? There is a two ways. One way is find out the determinant of A minus lambda I. What does it mean? Determinant of A minus lambda I? It means subtract lambda from the diagonal. Nothing else. Because lambda multiplies with I means lambda in diagonal. Now A minus lambda I means subtract from A lambda in diagonal and take determinant equal to 0 and then solve or expand as usual. We are expanding determinant. You will get one equation in lambda, and that equation when you solve by any method or by calculator you will get the values of lambda. That is one way. There are so many ways. I will tell so many tricks to know about the eigenvalues. And one more way is there, that also I will explain later when we do the question that time. And so this is the way how we calculate eigenvalues. Now how we calculate eigenvector? So eigenvector we calculate by this definition. once you calculated lambda from this, just put lambda here. So if it A is a 3 cross 3 matrix, we have third degree equation, and we know how many solutions are there? 3. So we have 3 eigenvalues, which is also called as latent root or characteristic values. So many names are there. So they can ask in any way. So basically we are telling in mathematics eigenvalue. When we are in control theory, we are telling a latent root. So once you calculated lambda, so we have 3 eigenvalues. Put each and every eigenvalue here one by one. Put lambda value something, whatever is there. Subtract a from lambda I, multiply with x. Take x value x, y, z and solve the equation. You will get the eigenvector. Just keep in mind, x must be non-zero. If it comes 0, it means wrong only. X must be non-zero. So in this way we calculate eigenvector. And in this way we calculate eigenvalue. Now I am going to tell about a shortcut method to write characteristic equation. What is that? Note. The formula is lambda cube minus trace of A into lambda square plus A11, A22, A33 of lambda minus determinant of A is equal to 0. This is for 3 cross 3 matrix formula. What is 2 cross 2? Lambda square minus trace of A into lambda plus determinant of A is equal to 0. So trace, you know, trace means sum of diagonal elements. A11, A22, A33 are cofactor matrix of A11 element, A22 and A33. You can find out easily. We will tell by an example. And determinant of A you can find easily. Just put the values in formula, you will get the equation directly. Here chances of mistakes very high. Here it's very less. So this is the way how we calculate eigenvalues. Now I am going to do one example. These two example for first. How we calculate? Suppose this is A matrix. So first of all we have calculate trace of A. What is trace of A? Sum of diagonal element. How much? 5 plus 2 plus 3. This is 10. Now what is cofactor for A11? A11 means for this, close this, what we get? 2, 6, 0, 5. What is the value? 10. It's determinant. What is A22? For this, close this. 3, 4, 0, 5. What is the value? 15. What is A33? Cofactor for this. So close this. What is the matrix? 3102. Determinant 6. Now, what is the determinant of A? 3 into 5 to the 10 minus 1 into 0 plus 4 into 0. So what is the value? 30. So what is the characteristic equation for this? Lambda cube minus trace. Trace is how much? 10. Lambda square plus A11, A22 plus A33. How much? 31. Lambda minus determinant 30 is equal to 0. When you solve this, what we get? Lambda value 2, 3, 5. These are the eigenvalues which you can easily check. See, lambda is equal to 2 satisfies this equation. So lambda minus 2 is a factor. So divide lambda minus 2 by that. You can get the values easily. Use remainder theorem to solve this one. So similarly, we can do this one. When you do this one, what is trace? Trace of this is 5 plus 1 plus 1. Total 7. What is A11? 5, 1, 1, 1. So 5 minus 1, 4. What is 8 to 2? 1, 3, 3, 1. So minus 8. What is 8, 3, 3? 4. What is determinant? 1 into 4 minus 1 into minus 2 plus 3 into minus 14. So 4 plus 2 minus 36. So what is the test equation? Lambda cube minus 7 lambda square plus 0 lambda minus 36 is equal to 0. So when you solve, what are the factors are there? Lambda value, see 235 minus 2. This is plus because minus is there. So lambda is equal to 235. We will check. No, lambda is equal to minus 235. So minus 8 for 28. 28 or minus 36. Plus yes. So minus 2, then 3 also satisfies. 37, 36. Yes, 3 then 6. Because definitely whatever factors are there, it will are the factor of 36. So that's why easily we can check. That is a different strategy to find out the root. But you are allowed to use calculator, so please use calculator and easily you can get it. Otherwise, use remainder theorem. So this is your choice. In this way, we can calculate eigenvalues. Easy way. There are some more tricks, but that will work in competitive exam, not for theory exam. For theory, either you go for which one? Either you can go by which method? Determinant method. What is determinant method? We have to write a minus lambda I determinant equal to 0. So it means determinant of subtract lambda from diagonal. So 3 minus lambda 1, 4, 0, 2 minus lambda 6, 0, 0, 5 minus lambda and take its determinant equal to 0. Find out its determinant. How will we find determinant? 3 minus lambda outside determinant. 2 minus lambda multiplied with 5 minus lambda, this is 0 minus 1 into 0, 0 plus 4 into 0 is equal to 0. So 3 minus lambda, 2 minus lambda, 5 minus lambda is equal to 0. So what is lambda value? 2, 3, 5. So don't think this is the easiest way to calculate eigenvalues. Here, because it's a low triangular matrix, so easily we came to know eigenvalues are this one, and easily we can expand. But when we go for this, it is quite difficult to calculate eigenvalues by this way. The best way is use formula always. Okay, so in this way we can calculate eigenvalues. In next lecture, I will explain how we calculate eigenvectors. Thank you.